Hello. Today we are working on energy diagrams for chemical reactions. So let's read the problem. Draw an energy diagram for the exothermic combustion reaction given below. Include activation energy. So when I read exothermic, the first thing I want to do is write heat in. Exothermic always means that heat is exiting, and therefore that means that heat is going to be a product. Now next I want to start drawing my graph. So on the x-axis, we always write in reaction progress. In other words, the reaction starts here and it progresses as we go. On the y-axis, we will see H for heat or enthalpy, or we might also sometimes see energy. Now, in an exothermic reaction, the reactants contain quite a bit of energy tied up in their bonds. And then as the reaction occurs, those reactants form new bonds, the products here, that contain less energy in their bonds. And the result is that energy, or heat, is given off. This here is the change in heat, or enthalpy, and it will always have a negative sign in an exothermic reaction. Another thing to note about exothermic reactions is they generally are spontaneous. You can think of going downhill here is fairly easy to have that occur. A ball will roll spontaneously downhill. But we all know that just because you have methane, say you leave your stove on, it's not automatically going to start burning or start combusting. The reason for that is activation energy. I want you to notice that my activation energy is just a continuation of the reaction. So it connects to the reactants, it connects to the products. This quantity of energy here is our activation energy, and that is the minimum amount of energy required for a reaction to occur. In other words, to get these methane molecules to start breaking bonds and forming new ones requires some energy to get those molecules to collide in just the right way that new bonds are formed. Depending on the size of the activation energy hill here, the bigger it is, the more energy that's required to get the reaction to happen. The smaller it is, the reaction would more easily take place. So just to add a little bit more color onto our page here, let's make a list of all the things that go with an exothermic reaction. The first one, heat is released from the reaction, or exits. Exothermic heat exits. Next, delta H is negative. That was the difference between the reactant energy and the product energy. Next, the reactants are higher in energy than the products. Right along with that, the reactants contain more energy in their bonds than the products. Finally, the reaction is downhill in an exothermic reaction, and therefore usually spontaneous, because it's easy to roll something downhill once you supply that bit of activation energy. So there you have it. We have a few different things here that we can look for in every exothermic reaction, and a diagram to go with that. Just to quickly add on to that, this is all true of our exothermic reactions, but all of the reverse principles and the sketch would be true of endothermic reactions. So I'll show you a picture of that on the next page, along with how a catalyst would change this diagram. So here on the left is an endothermic energy diagram. Everything is still there. The only difference is that the reactants start with less energy than the products end up with, and so in the process you have to absorb energy to get up to the products. And then finally we'll look at what a catalyzed reaction diagram looks like, and in that case all that is affected is that the activation energy is going to become lower because a catalyst helps the reaction occur in a more easy fashion. So this reaction on the right would be the same exact reaction as the one on the left. The delta H has remained the same here. The only difference is the magnitude, the quantity of energy that is required to make the reaction happen, and that is a much smaller amount than we saw over here. I could overlay that onto this diagram here by showing that the catalyst has lowered the amount of energy that it requires for the reaction to happen. So hopefully that helps you with your drawings.